This week we're going to be looking at the space strand of the mathematics curriculum. This is an interesting strand of the curriculum. Unlike the other strands of the curriculum where there's a lot of number work, whether it's measurement or chance and data or the number strand itself or algebra, there's always a lot of number involved in that strand. The space strand is quite different from those other strands in that there is number involved in this strand, but there's a lot more about representation, or when we talked a few weeks ago about the literacy, numeracy and graphacy, there is a lot of graphacy in this strand as well as number. So it's actually a unique strand of the curriculum. So what are you going to be doing when you're working with this strand in the early years? First of all, there's a lot of shape that needs to be taught, and one of the things that we need to make sure you get your language right on this one, and I've alerted you to it earlier in this course, is that we often refer to two-dimensional objects as shapes, and three-dimensional objects as solids. It's easy to slip into the language of saying that three-dimensional objects are shapes as well, as in a cube is a shape and so on. But please try, if you can, to keep the differentiation of those words separate, because if you could imagine a child, when you're talking about a cube and you're talking about the shape of the cube, and they've been working with two-dimensional shapes and they've been told that they're a square, they're often going to look at the face of that cube and say it's a square, and in some ways they're right. So we try and differentiate by using those two different words. What you've also got to do is they've got to be able to recognise what those shapes and solids are by name, and they also need to be learning about the properties of those shapes and solids. So when you're talking about a square, and so the words we use are faces, edges and vertices. So when we're talking about the face of a cube, we know that its shape is actually a square. So you can see now where the language starts to become very important, and where if you create slippage in that language, it creates confusion for the students. Pardon me. So what we do is we start off with the basic shapes. So there are four basic shapes that we initially start with are a rectangle, circle, square and triangle. Now often what you'll see when we're teaching those shapes, have a look at the way I've represented them there. What we know is we have the baseline always running on the horizontal axis. It's a convention that we've adopted, but it also creates a lot of confusion. So we need to play with that, and we need to rotate shapes, and we'll talk a little bit about that in a minute. But we do need to challenge some of those conventions, because what happens when you look at the next example here, when you look at this example, what you see is when in our early years, students will see this shape here, the first shape, as a square. When they have a look at this second shape, because it's been rotated through 45 degrees, it's now not a square, and they'll often say it's a kite, but it is actually a square. It's just been rotated through 45 degrees. So we need to play with those conventions so that in the end, the students are able to recognise both of those two shapes as actually being squares. Now, part of the idea of challenging conventions comes from the work of Van Heelys. They were Dutch mathematicians or mathematics educators, and they looked at applying Piaget's notions of stage theory to geometric thinking. And for the early years, the two things that you're most concerned with are the first two levels of the Van Heely levels of thinking. So students often think about shapes as they are presented. So they recognise a square as being a square because it's a square. And that's why they'll get the second shape that we just talked about. When you rotate that square through 45 degrees, it's now not a square, it's actually a kite or another shape, because it's not the square as being a square. So they only recognise shapes as a shape because of what it is. So the second stage is which is where you'll be working towards through the early years in the school sector, is they'll start to recognise shapes through their properties. So often a square and a rectangle might actually be seen as the same shape if they're close to being a square. However, as they start to see properties, they'll only recognise one property at a time. Subsequent levels are recognising the interactions between properties and so on. But in the early years, these are the two that you'll be concerned with most. So the second level is when they're starting to recognise shapes through properties. Now those properties will be a square is a square because it's got 4 equal sides. And a rectangle is a rectangle because it's got 2 sides that are equal and 2 sides that are longer, or 2 sides that are shorter, whichever way that is. And a triangle is a triangle because it's got 3 sides. Now those sides may not necessarily be equal, but they will have 3 sides, and that's why they're able to understand that an equilateral triangle is the same as a scalene triangle, which is the same as an isosceles triangle, because they've all got 3 sides. So that's where you'll be looking a lot of and directing a lot of your teaching. So in the preschool years, a lot of the work will be around just recognising those basic shapes. Once they've got those, you might start to introduce shapes like ovals or pentagons or hexagons. But we focus primarily on the basic shapes. So that's kind of what you'll be looking at in terms of the shape component of the geometry strand. We also need to look at transformative geometry. And transformative geometry simply means we're transforming. That means changing. Now there's 3 basic transformations in geometry. The first is the slide, which is the first one, where the triangle just moves along the same axes. So it could be vertical or it could be horizontal, but it's just simply a slide. The second one is a flip, where there's a line of symmetry and then it's flipped, as in like a reflection across that. And the third one is a rotation. So what you see on the right hand side is the same triangle, but it's gone through a transformation. This is a really important part of geometry, and I'll talk a little bit more about this later on. A lot of children have significant challenges in terms of creating mental images and transforming them in their mind. So we need to do a lot of work with this part of the transformative geometry. In the early years, one of the ways that we do a lot of this is through tessellations. So we give the children, for example, these blocks, and then we get them to tessellate. And tessellate simply means it's like tiling your floor, so that things are put together, and the key part is that there are no gaps. So some shapes will tessellate and some won't. So circles, for example, won't tessellate. So what we need to do is play with those. We give them a lot of blocks, and they have to do a lot of transformative geometry to get shapes to fit together. So you can see, if you had that the triangles on the left hand side, to create no gaps, then you're going to have to do flipping and rotations to be able to fill in those gaps. So tessellations is an important part of transformative an important application of transformative geometry. The other part of the geometry strand is location. And location, unlike we're not exploring shape anymore, what we're looking at now is our place in a particular space. So a lot of the work around location, you'll see location is the start of our mapping, our general mapping skills, and we start with really simple things like draw your way home. The kids, and this is a really fun activity to do with a lot of the children, their maps aren't to scale, their maps are all out of proportion, but a lot of their proportional representation is about the significance of those roads. So if they're driving to Brisbane, that's a very boring road, for example, if you're going between the Gold Coast and Brisbane. So it might be represented as a small line. But as they get into their own neighbourhood, they know there's their friend's house here, and there's a shop here, and there's a school there, and then it becomes much larger because in their heads those places are more significant, so they occupy more space on their map. What we're trying to do in the location strand is getting the students to represent location according to the conventions that we have in our mapping skills. However, in the early years, we're just getting the students really to think about their place in space. There's a rich vocabulary in this strand that you need to develop. So when we're talking about early location, a lot of the location is about putting blocks beside each other, next door to each other, and developing this rich vocabulary. And here are just some examples of what that vocabulary is: above, next to, near, beside, behind, on top of, left, right, and so on. Now, all of those words are only in relation to, say, one block and the next. So can you imagine once you start to put 3 or 4 blocks together, representing in a 2-dimensional space and a 3-dimensional space, what does it mean in a 3-dimensional space for something to be behind or next to? It could be the same thing, but it's different. So you have to focus on developing that rich vocabulary. You may not focus as much on the formal locational vocabulary, so north, south, east, and west. But it's a vocabulary they also need to hear. Now, a really nice example of location that I can share with you is I worked, as I've said before, in Central Australia. Now, many Indigenous people have an acute sense of space. They have, it's often said, they've got an inbuilt compass. When mothers talk to their babies, they don't use the words of above, next to, and beside, and left and right, because they're all relative. So if you look at a house on one direction and you see the shop is to the left of it, that's because of the way you're looking. If you go to the back of the house, now the shop is to the right. So in many Indigenous cultures, the mothers will actually, and fathers will actually be talking about the house is to the north or to the south of. And then it becomes, it's not a relative concept. The house is always, the shop is always to the north of the house, whether you're standing at the front or the back or the behind or in front of or wherever. So this concept of north, south, east and west is something that's built into some cultures. In our culture, we talk a lot about the relative positional language. So we need to develop both of those languages. The north, south, east and west will come in our curriculum later than the informal language. However, you must develop this language because if you think about every one of those words, they can all be said in relation to one object to the other. So it's a very complex language that needs to be developed for the students. The space strand has very, very profound equity implications. There's often an assumption that boys do better at maths and girls do better at language activities such as English and the social sciences. However, what we have found out that the gender differences that we see in mathematics aren't across the board in mathematics in all strands. Where they are really evident is in the space strand. So we need to make sure that we provide a lot of spatial activities for boys and girls in this strand. And where the most gender differences are in this strand is when we're asking students to do mental transformations. So when we talked earlier on about the transformative geometry and creating mental images, rotating them, what they might look like, this is an area that we must develop a lot more with both boys and girls. There are theories about why that happens. In your early childhood setting, look at where the girls play and look at where the boys play. Girls are generally, and this is a generalisation, are generally more likely to play in the house corner. Boys are more likely to play in the block corner, and they're also more likely to be playing outside. So if you think about what those boys are doing as they're doing their everyday play, in the early childhood centre, for example, they're developing a much more acute sense of space and how they put the blocks on different angles, different rotations. So they're embodying many of those spatial experiences which potentially help them later on in the space strand. So we need to make sure that girls have as much access to many of those spatial experiences as their boy colleagues. The other area that's very profound in the space strand is for many of the socially disadvantaged, culturally disadvantaged and linguistically disadvantaged students that we have to come into our class. The space strand is the richest strand of the mathematics curriculum when it comes to language. So we have more words in the space strand than we have in the other strands. So for students who are coming from low SES backgrounds where they have what Bernstein calls a restricted code for English, students who come from backgrounds where English is not their first language, is not their home language, those students are likely to have less access to the rich vocabulary we use in space. So as a teacher, you need to make sure that your space strand is language rich and you provide scaffolding for your equity target group so they're able to access the language of the space strand.